Assalamu alaikum students, this is Farwa Batul, your O-level computer science instructor, and welcome to another video of chapter number 10, Boolean logic. In the previous video, we are done with example 1, 2, 3, 4. In this video, I will be doing example number 5 of your book. This example has two parts, A and B. So first of all, we will do part A. The example says that which Boolean expression is represented by the following truth table. It means that you have to produce a logical expression through the given truth table. Okay, so I'm quickly reviewing all the rules of producing a logical expression out of a truth table. Rule number one, step number one is to consider only those rows that has a value 1. Consider only those rows with output output 1, which means that here you will be considering this one with the value 1, then you will be considering this one, the ones that are highlighted already, this one and this one. These three rows will be considered. The second thing that you have to do is make logical expression for each of these rows. Logical expression for each row. And remember, there is a rule that if your input is 0, you will make it not A. For example, such that if A equals to 0, you will write A as it is. And if A is equals to 1, you will write it not A in your logical expression. And then you have to join them with AND. Join your inputs with AND. So look at here. First of all, let me just mark it with row 1. This is row 2. This is row 3 that I have to work in. So for row 1, A is 0, B is 0, and C is also 0. So what you will be doing, you will be writing not for all of these. It will be not A, not B, and not C. And remember that all of these inputs are going to be joined with AND gate. So write down AND in between these inputs. This is row 1. Now quickly doing for row 2. Okay, in row number 2, look over here. A is 1, B is 0, C is 0. So write over here that A is 1, B is 0, and C is also 0. So what you will be doing, you have to write down A as it is, B with a not, and C with a not C. Once you are done with writing your inputs, now join them with a two AND gates in between them. It's done for row 2. Now let's do for the third row with a value 1 in the output. Okay, so look here. The third row has 1, 1, 0. So I'm writing it down. A equals to 1, B equals to 1, and C equals to 0. So very easy. What you have to do, write down A as it is, write down B as it is, and for C, you must be passing this through an inverter. Okay, so write down AND between these input values to make it the logic expression. Okay, once you are done with all of these rows, the final step would be, now Um, it will be the third step in which combine all logic expressions, all expressions for rows for row 1, row 2 that you have already done, and row 3 with or gate. It's the final step. So what I will be doing, I will just write down the final logic expression, and it will be for row 1 it is not A, not B, not C. So write down not A with and, not B and, not C. This is your first expression, raw one. Remember to put a or gate in between. Now the second row is A and not B and not B and not C. It's done. Now put a or to connect it with the third value or third expression, row 3. A and B and not C. Okay, so this is done. This is basically your answer or your logic expression for the given truth table. This is how you have to write down, or you have to produce the logic expression for a given truth table. Part A is done. Now quickly moving towards part B. Okay, so here we go. This is part B of example number 5. Again, what you have to do, this part B has two another parts. So what you have to do, let's start with the first one. You have to find out the logic expression, and the given truth table is over here. It's a truth table and you have to find the logic expression of that. Okay, so first step is to consider only those rows that has the input value 1. So look over here, the first one, this, and all these three. So it is all together 1, 2, 3, 4. 4 rows.
Miss Jenny, please come to my office. Thank you.
Let's quickly start for first row. Okay, so for row 1 it will be, remember the value of A is 0. So A will be written as it is. Then B is, sorry, if A is 0, so we will write it not A. Let me just clean it for you. It will be not A. Remember, if values are 0, we will write not A. Then B written as it is and C written as it is. And remember to write down and A and D and between these three inputs. Now quickly doing for row 2. In row 2, look over here. This is 1, 0, 1. So 1 will be written, A will be written as it is. Then you have not B, and then C will be written as it is. And remember to write and in between them, A and D and A and D and like this. Now row number 3. So row 3, it will be 1, 1, 0. So it means A as it is, B as it is, and C will be 0. So it is not C. Write down and between the inputs for each of these rows. Now let's do for row 4, the last row with a value 1 as the output. So it is 1, 1, 1. Easy peasy, write down A, B, C and write down and in between them. A and D and A and D and. So this is how we are going to write down the expressions for each row. Now the final thing is you have to connect all of them with OR. So nothing, the final expression, logical expression or logic expression, not logical, logic expression is just writing down all of them together with OR gate. Remember to connect all of them with an OR gate, which is the final step. So it's not A, writing the raw one, and B and C. Remember to write down OR, then it is A and raw 2, not B and C, then OR, write down raw 3. If you don't have a space, you can write below A and B and not C. Another OR, the raw 4 will be A and B and C. So this is going to be the final logic expression for part B. Okay, so we are done with part A and B. And in B, we have already done number 1. Now let's move towards the second one, the second part of this example number 5. So the second part says that show that your logic expression in part 1 is the same as this one. So what you have to do, just write it down, the logic expression that we did for part 1. I'm writing over here and then we will see that how to solve this part. Okay, so here we go in part B. What you have to do, the logic expression in part 1, which I have already pasted over here. This was the truth table and this was the logic expression that we worked on. Now what you have to show that this logic expression is same as this one that is given to you in part 2. And let me just quickly write it, that we have to say that if it is same as B and C, or A and C, or A and B. So we have to just confirm that whether two of these logical expressions are same and not. And the easiest way of doing this is to make a truth table. We already have the truth table for this expression. So we will be making a truth table for the second, this one. And once we will do it, then we will see the result of both the truth tables. If the column X of both truth tables are same, then we can say that yes, these two expressions are same. So let me quickly make a truth table for this given expression, logic expression. Okay, so here we go. This is a truth table for the given, for this expression. Let me just quickly tell you that what are the columns. The first, we have 3 input values A, B, C, and since we have 3 input values, so the combinations will be 2 raised to the power 3, which is 8, and input combinations are already written over here. These are the 8 different combinations that we can give into this circuit. First column represents B and C. The second column represents A and C, and the third column will be calculated by A and B. And once we are done with all of these columns, then we will perform OR operation between all of these 3 columns. 1, 2, 3. There will be a OR operation between them, or a simple addition of the binary bits. So let's quickly do for the first column, B and C. It means in which for B and C, we have to consider the column B and column C and just perform the multiplication between these 2 bits. 0 into 0 is 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1, 0 into 0, 0, 0 into 1 is 0, 0, 1 into 1 is 1. This is done. B and C. Now quickly do for A and C. So consider the columns A and C for this second column. Okay, 0 and 0 is 0. Just multiply it. 0 and 1 is 0. 0 into 0 is 0. 0 into 1 is 1. 1 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. 1 into 1 is 1. Let me quickly see that. 0 into 0, 0. 0 into 1 is 0. 0 into 0, 0. 0 into 1 is 0 again. Look over here. 0 into 1. It's 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. And 1 into 1 is 1. So you need to be very, very careful. Otherwise, you might make some mistakes. Now, number 3. Number 3, you will be considering A and B only. So, let me just clean everything over here so we can calculate it easily. Okay. So here we go. Just column A and column B and perform AND operation between them. 0, 0, 0. 0 into 0, 0. 0 into 1 is 0 again. It's multiplication. 0 into 1, 0. 1 into 0, 0. 1 into 0 is 0. 1 into 1, 1 into 1 will be 1, 1. Now, once we are done with this, the last column is going to be the OR operation between all of these three columns. Look at the expression. The expression says that all these three expressions are connected together with OR operator, and OR is nothing but the addition of your binary bits. So you can simply do that. 0 plus 0 plus 0 is 0. Then 0 plus 0 plus 0, again you have 0. Then 0 plus 0 plus 0, again you have 0. It's a binary addition. 1 plus 0 plus 0 is 1. 0 plus 0 plus 0 is 0. Then 0 plus 1 plus 0 is 1. 0 plus 0 plus 1 is 1. 1 plus 1 plus 1 is 1, because it is binary addition in which when all of the bits are 1, you will write 1. So this is your output. You can simply write all of these values as x. So it is 0, 0, 0, 1, 0, 1, 1, 1. Now let me just see if these matches the table that is given to me in part B for the expression here. So in part 1, look at this. The column x was 0, 0, 0, 1, 0, 1, 1, 1. So if I match them, look over here. Look both of these tables. This one and this one. First one is 0, second is 0, third is 0, fourth value is 1, then fifth value is 0, then you have 3 ones. So we already proved that both of these expressions, that was in part 1 and that was in part 2, they are same. Why? Because the x, or the output values for both logic, simply you can write the output values x for both logic expressions are same. That's it. So we are done with example number 5. Stay tuned, stay connected for more examples. Take care. Bye bye.